So in this class, we're going to discuss reliable data transfer over the channel with the bit errors, RDT 2.0, sender handles how garbled acknowledgement and negative acknowledgement so in RDT version 2.1, and how sender uses acknowledgement and negative acknowledgements in the version RDT reliable data transfer protocol 2.2 versions. So RDT 2.0 channel with the bit errors. So underlying channel may flip bits in a package. Checksum is detect the bit errors. So any errors are rare. It is responsibility of the checksum to detect the bit errors. And the question is how to recover from the errors. Acknowledgement is received and explicitly tells the senders and the packet is received is okay. So negative acknowledgement, as and when negative acknowledgement is received and receiver explicitly tells the sender that packet had errors. So there is a positive acknowledgement, so receiver is receiving. So as acknowledgement, negative acknowledgement is an EAK, is a negative acknowledgement. Sender retransmit the packet as and when so negative acknowledgement is received by the sender. So new mechanism in RDT 2.0. So beyond RDT 1.0, error detection and error feedback, and that is a control messages. So that is so acknowledgement and a negative acknowledgement. So receiver, so as and when receives that, so that is exactly, so that is the sender has been sending that is the data. So definitely it is receives. So this kind of so that is a feedback information, acknowledgement or positive acknowledgement. How do human recover from the errors during the conversation? So that is a question also arises to see that. So in RDT, so that is exactly the checksum underlying channel may flip bits in the packet. Checksum to detect the bit errors. The question how to recover from errors. So that is exactly acknowledgement. Receiver explicitly tells the sender the packet is received is okay. So that is a negative acknowledgement. That is exactly same thing. So here there is a feedback control messages. So I think already discussed this one. So this is the FSM specification, RDT 2.5. So as you know that wait from call from memo application layer, it is a waiting from the so as a data. So that is a send the data. So send the packet, make a packet and data, check some data. This is exactly wait for acknowledgement. This is one state to another state. So exactly it is a sending a data. Again you can see that this is exactly in the sender side. This exactly so receives the data, send the packet, send the packet. It is exactly so send the packet, again receives the packet, wait from call from below. So with the no errors, if it is no errors, so exactly so your packet will be so getting acknowledgement back to the. So this is acknowledgement received by the packet. So as and when this is exactly the two state. So the state one to state two. So normally FSM two FSM. This is in receiver side FSM receives the packet and unity send the. So as and when receives the so with the errors. So negative acknowledgement will be sent. So if there is no errors in the packet, so positive acknowledgement. So whether it is so that is exactly so operations with the so no errors. This is FSM operation. So error scenario. So if it is a errors in the packet, so make a packet checksum. It is wait from callable. So as you know that it is acknowledgement will be either acknowledgement or negative acknowledgement. When it is a negative acknowledgement, so definitely it is delivered to the proper destination call from below. So exactly it is received by the so negative acknowledgement is received with the so having errors in the packet. So negative acknowledgement will be. So that is exactly that two. So the state here. This is extract the packet. So this is the one state here and deliver the packet to the proper destination. So negative acknowledgement when it is received. So with errors. So there is error in the packet. So definitely negative acknowledgement will be so receives. This is scenario. So RDT 2.0 is a crash block. What happens in the acknowledgement if acknowledgement and corrupted? Sender does not know what happened at the receiver. It can't just retransmit possible duplicate error. So it is a sender does not know what happened into the receiver, whether it is a packet is a so in between is corrupted or not. The sender may not be know, but it is retransmit the possible duplicate same packet again. So how handle duplicate error? So that is a sender retransmit the corrupted packet. So with the acknowledgement only sending Again, second packet will be so delivered back by the sender to the receiver. Negative acknowledgement is nothing but it is a corrupted packet. Again, retransmit the same packet. So again, sender adds the sequence numbers. So how adding the packets? So for every packet there is a packet one. So that is a sequence number one. Packet two, sequence number two. Second packet three. So like that, sequence number it is added to the each packet. Receiver discard. So as we know that suppose duplicate packet same two is received twice. So one packet will be discard. So it does not deliver to the duplicate packets. So this is how exactly the handling duplicate packet. Stop and wait protocol. So it is a sender sends the one packet, then wait for the receiver. So this is also called as RDT version 2.0 as a stop and wait protocol. Sender sends the one packet, then wait for the receiver to the response. So wait for the receiver either positive acknowledgement, negative acknowledgement to be a response from the receiver. So here, so this is exactly the version 2.1 tells that sender handles the garbled acknowledgement or negative acknowledgement. You see that that is the scenarios. So this is exactly the FSM wait for confirm. Same scenario what I already explained. Send the make the packet and check some immunity set the reception and corrupted packets. So we will check either positive or negative acknowledgement. So each and every packet. So for example, acknowledgement. So that is so for the first packet 0. So positive acknowledgement. So that is delivered to the proper destination. So suppose if it is a not delivered, so negative acknowledgement 0 will be sent. So if it is a second packet, so positive acknowledgement, if it is delivered to the negative acknowledgement will be delivered. So as and when packet is not so received by the receiver. This is what they're explained here. So that is a garbled. So it is a duplicate packet will be entered with the sequence numbers. That is what so here FSM explained. So again, 2.1, it is a so receiver handles the garbled acknowledgement is a continue. This is the entire thing. So that is exactly wait from call from above. So that is a wait from so below. So that is exactly the so events has been occurred. So everything they are explained very clearly. So I think these things already have explained. So if it is a corrupted packet or it is a not corrupted packet, so it is a delivered to the so send the wake packet. So if it is a packet has been already, it is a so it is a corrupted, so it is a negative acknowledgement. If it is not corrupted, positive acknowledgement delivered back to the so that is a sender. So here RDT 2.1 discussion under sequence number will be added to the packet in RDT 1. So sequence number, so stop and wait protocol. So two sequences, so 0 and 1 will be suffice. Why? It must be checked if it is received the acknowledgement or negative acknowledgement has been corrected. Twice as a many states, state must be remember whether it is expect the packet should have a sequence number 1, 0 or 1. So either 0 or 1 it is a so as mentioned, receiver must check whether it is received packet is a duplicate packet. State indicates whether it is a 0 or 1. So except that packet sequence number, so that is a 1 or so 0 or 1. So note receiver can not opt if last acknowledgement or negative acknowledgement received. Okay, whether it is a positive acknowledgement, when positive acknowledgement received, if the packet is delivered so to the correctly to the destination. So that is a positive acknowledgement. If it is a negative acknowledgement, if it is a packet is not delivered, so that is exactly receiver sent back negative acknowledgement. So or if it is a corrupted packet also negative acknowledgement received. So up to that, so by that, so okay at the senders. Okay. So here, so in 2.2, so as a negative acknowledgement free protocol, same functionality as a 2.1. So using so here is 2.1, normally there is a sequence number. So it is a stop and wait protocol continuation. So sequence number it is adding with the positive and negative acknowledgement. So using acknowledgement only, so instead of negative acknowledgement, receiver sends the acknowledgement for last packet, okay. Receiver must explicitly include the sequence number being acknowledged. Duplicate acknowledgement at the sender results the same action as a negative acknowledgement and restarts with the current packet in case of a negative acknowledgement free protocol. So here in RDT 2.0 sender and receiver fragments, so FSM is also delivered same way. So wait for call from above. This is the event is occurs. So make the packet UDT send the packet. Wait for this is another event. So that is FSM 2. So wait for so positive acknowledgement. So that should be whether it is a UDT send that positive wait for. So this is how exactly the FSM works. I think these things already have explained. So that's sender fragment. and receiver fragment, that is a FSM. So they're given. So here in this class, we have discussed about reliable data transfer. So the channel with the bit errors in 182.0. So it is also called a stop and wait protocol. So it is a version 2.1 is also explained with how exactly we handle the garbled acknowledgement and negative acknowledgements, and we can use this that in version 2.2. It is used as acknowledgement and negative acknowledgement. So with the FSM already we have discussed.